So, in this topic, what we'll be doing is quadratics, okay? So, you should know linear. So, can you give me an example of a linear equation? What's an example of an equation? Y is equal to what?
mx.
Mx plus c?
Yeah, mx.
That's the general equation. Give me an example of an equation.
Y equals 2x plus 4.
Yeah, okay? So, that is an example of a linear, okay? And what makes it linear? It's a line, isn't it? So basically a graph looks something like this, okay? And that's your graph, it's a line, right? And basically, what's the power for this x?
Nothing.
Is there a number?
Oh, yeah, 2.
But, oh no, here there's a 2, that's coefficient, but what's the power?
There's one.
So what does that then mean if there's no power? You think it's 0?
1.
1, yeah, correct, but you can't see it, right? So the whole part about quadratics is that you have it usually looking like this. Okay, so in quadratics, you have a power, and it's usually 2. It's always 2, right? So usually the power is always 2. So that's y equals x squared. And in quadratics, you usually have, so in a linear, where's your y-intercept?
Vertical.
It's on the vertical axis,
Yeah.
correct, yeah. So your y-axis, your y-intercept is where the line crosses the y-axis, which is here. Your x-intercept is here, right? In this scenario with quadratics, where's your y-intercept? Is it here, here, or here?
The bottom.
Yeah, so this one, right? Where's your x-intercept?
Well, there's 2.
There's 2, correct. So there's 1 here and there's 1 there.
That's where the power comes in.
Yeah, and I'll show you. Let's say for example, yeah, let's say for example, you had, let's say, so I'll go into that in a bit more detail, but that's what it looks graphically. Okay, that doesn't represent that equation. This doesn't represent this equation. Okay, but essentially that's what a quadratic graph looks like. So you got x-intercept here, and you got another x-intercept.
Yep.
So there's 2 x-intercepts, not all the time, and I'll show you examples of why that's the case. But sometimes you have 2 x-intercepts and a y-intercept. All right. So now we'll go over factorizing. Okay, so showing you an example of factorizing. Okay, so if I said 2x plus 18, how do you factorize that?
2 bracket x plus 9.
Well done. Okay, that's basic factorizing.
Yeah.
Okay. Now, what about if I had x squared plus let's go with 11x plus 18. How do you factorize that? What's the way to do it?
Don't.
And this has got to do with factorization, but trinomials. What's in the word trinomials? 3, yeah. Yeah, there's 3, right? So there's 1 here, 2 here, and that's a third. Nomials means names. I might be wrong, but in Latin it means names. So there's 3 different names, 3 different terms. How do you factorize these?
Find common factors.
Right? That's the basic understanding about factorizing, but there's a way to go about it. There's 2 numbers that multiply to get you 18. 2 numbers that add
Yeah, I remember this.
to get you 11. So what you're going to do is when you multiply something, what are the 2 things called when they multiply each other? Factors. Yeah? So what we can do is start with 18. 1 and 18, 2 and 9, 3 and 6. Now, one of these could also be negative numbers, right? But looking at that, what are 2 numbers that add to give you 11 but multiply to give you 18?
2 and 9.
2 and 9. So you got these two factors and they're positive. So basically when you factorize it, it's x plus 2, x plus 9. Okay, so let's say that's the equation of the graph. Y is equal to that. You got to factorize it. What's the factorized version? Okay?
X squared.
So, if you expand this, you're going to get this, aren't you?
Yeah.
But we don't want to do that. Alright?
We just want to factor it.
We want to factorize it. Okay, so now that's how you find out your x-intercepts. You have to factorize it, right? But firstly, in any question, what do you know about any x-intercept? What's one fact or one point you know about x-intercepts? Every x-intercept.
It goes horizontal.
Well, the axis is horizontal. What else do you know about this particular point? So let's say that coordinate, that there is 1, and it goes through 1. What about this one? What do you know about this and this? What do they have in common? What does these three have in common?
They're all on the line.
They're all on the x-axis. But what else do you know? Do you know any other values at that particular point?
There's negatives.
You got negative x values?
Yeah.
Yeah? But what's common between this, this, and this? What about the y value? What's common about all these y values?
They're all on the y-axis.
Yeah, where's the y-axis? Here.
Yeah.
But what do they all have in common? What's the value at y at this point, and this point?
0.
0. So y is equal to 0 here, y is equal to 0 here, y is equal to 0. So essentially, to find any x-intercept, what do you make y equal to?
0.
0. So this guy over here becomes 0. So you got x plus 2, x plus 9. And to cut it short, okay, because I know we're going to have to cut this short, the way you find out your x values is you're going to solve. You know how we solve for x? Yeah? Yeah, so this is called the null factor theorem. We haven't gone through it a lot. Essentially, you're trying to solve for this x and solve for this. So what is this? X plus 2. To solve it, you're going to make it equal to 0.
Yeah.
Okay? Then, how do you solve for x? What do you need to get rid of?
I'm going to get rid of the 2.
Yeah, how do you get rid of the 2?
Minus it.
Minus it. So you're going to minus this side and minus this side, and it's going to be minus 2. And actually, technically, you should write it here. The reason why is because you can easily see it, right? 2 take away 2 is 0. So you got x is minus 2. This one here, x plus 9 equals to 0. X is equal to minus 9.
Yep.
So these give you what? What do you think they give you?
They go on the x-axis. They're kind of like the line.
Yeah, but what from this is an equation of a line, graph of a quadratic graph, right? A general quadratic graph. Let's say it looks like that.
Oh.
What do these mean? This x and this x on a graph.
They're like a power.
The power, okay, but the solutions, right? What does that mean? X is that. What do we make y equal to?
0.
0. So, what do we call those particular points? So what were the x is equal to negative 9? Let's say that is the negative 2, negative 4, negative 6, negative 8, and negative 9. So x is negative 9, x is negative 2.
Yep.
We need to make a quadratic graph. So what do you think this 2 and this 2 mean?
It means that there's no y-intercept. They don't. Oh.
They could have a y-intercept. The y-intercept could be here. So your graph essentially means that this graph, it goes like that.
Yeah.
It goes through these 2 points.
Yeah.
So when you factorize, then you're going to solve for x. You're finding out your x-intercept.
Oh, okay. Yeah. That
Yeah? So basically, x is negative 9, x is negative 2.
Yeah.
So I'll write here when you factorize, and then you solve, it gives you your x-intercept. All right? Now, how do you find out your y-intercept?
You just make x 0 and do the same thing.
So what are you going to do?
Make x 0.
Yeah, correct. So to find out your y-intercept, so I'm just going to wipe that off.
Make x 0 and solve.
Yeah. So find out your y-intercept. Let's just draw this. Okay, bang. Any y-intercept, your x is equal to 0.
Yep.
Right? So let's make x equal 0. So what was your equation? Y is equal to
0 plus
0 squared
yep.
plus 11, open bracket 0 plus 18. What's 0 squared?
0.
0. 0. What's 11 times 0? 0 plus 18. That's 18. Y is equal to 18.
Okay.
So that's your x-intercepts, and that's your
Y.
y-intercept. Great. So let's actually draw that. So this is your graph. You got your y, and you got your x. And we said negative 3 is here. What was it, negative 2, yeah?
Yeah, it was negative 2 and
Negative 9. Okay. And then your y-intercept is 18. So you gotta, when you get a graph, you gotta figure out, okay, what am I gonna do? What scale am I gonna use? Let's go 3, 6, 9, or for this case, because it's such a tiny graph, let's go up by 6s.
Okay.
Do you see how that would make sense?
Yeah.
If I did like 3, then I'm probably gonna end up here. Okay, so now you got your y-intercept there, you got your x-intercepts here. There's one more part that we have to find. So for any graph, which part do you not know of this graph? On there. What do you not know?
We don't know the gradient.
The gradient?
Oh.
Not exactly. So you got this and this. Like, can you just draw it like this? Like, what's the differences?
Yeah, we don't know that.
That particular point, right?
Yeah.
That's called the turning point. So, I'm just gonna rub this off. So, you have the graph again, and you had what? X, negative 2, and let's go negative 4, negative 6, negative 8, negative 9. Now, where does a graph usually turn? Which distance do you think it's going to turn?
Around the middle.
The middle. Well done. So how do you find out the middle between negative 2 and negative 9?
Just subtract.
Correct. Yeah. So what's 9 take away? What's the distance between this part?
Negative 7.
7, right? Then how do you find out the halfway point of 7? What's a half of 7? 3.5. So what you're going to do is you're going to get your answer there. It's going to be 3.5 from this 2.
Okay.
So 2 to negative 4 is negative 2. And that's going to be negative 3. And that's going to be somewhere there.
Okay.
3.5. So what's negative 2 plus 3.5? Negative
Negative
5.5. Okay. So basically, if we know the turning point is there, how do we find our y value? And that's your equation. What are you going to do with x is equal to negative 5.5? How do you find your y?
Do we make that 0 and do the same?
Well, make this 0, the x. So we got our turning point, right? But we don't know the y value. We know that's the equation, but we know our x. How do we find our y? So you know this value, x is equal to negative 5.5.
Yep.
We're simply just going to substitute it in here.
Oh,
And we're going to substitute in there. What are we left with? Then, if we substitute in all of those, we're going to be left with what?
the 18. The
Y is equal to negative 5.5 squared plus 11 times negative 5.5 plus 18. And then you're left with a y value. Alright? That's how you're going to go about it. That's how you do that question. So you get your x value, which is your halfway point, and you're going to substitute that into that. And that's how you find out your turning point. Do you have a calculator?
Yes, I think.
Could you work that out? So y is equal to negative 5.5 squared plus 11 negative 5.5 plus 18. So that will give you a y value. What's the y value?
I think it's flat.
What's the y value?
I think it's flat.
Oh, it's flat. Okay. So anyway.